Hello, my dears. In this tutorial, I'll show you how to program the jump and double jump in 3D. Before start, I want to mention that I've already set up the necessary animations for jump, fall, and double jump. I'm utilizing an animator controller, a script I defined in one of my previous videos. If you'd like to use mine, you can download it from the description on this video. Now, let's get started. Let's start by creating a script called Layer Checker. I'll do this in the scripts/physics. Let's open the script in our editor. OK. Now, we're going to write the following variables: target layer, range, and hit. Afterward, we will write the following code. This code defines a property called isTouching, which returns a Boolean value based on whether a collision is detected downward from the current position of the object. Now we need to write the next code. This code, enclosed within #if unity_editor and #endif preprocessor directives, it uses the onDrawGizmos method to draw a visual representation in the scene view for debugging purposes. The gizmos line is colored green if isTouching is true and yellow if it's false. Let's go to the Unity editor and assign the Layer Checker script to the 3D model. In my case, it's this small character. Also, we need to create a new layer. I'll call it ground. Afterward, we choose Target Checker, ground. Additionally, we have to change the layer of the model representing the ground. If you've done it correctly, you'll notice that when the line touches the object representing the ground, it changes from yellow to green. Now, let's incorporate the necessary code that provides the status of the jump button every time the user presses it. In my case, I have this script called Input Controller. If you don't have it, you can implement it in your script responsible for obtaining input states. If you prefer to follow my approach, I've included a link to my script in the video description. They are on Google Drive. Now, let's access the script that manages your character, which, in my case, is the Lila controller. We're going to introduce several variables. Under the jump section, we have a ground checker of type Layer Checker, a jump force set to 90, and a max jump height set to 14. Moving on to the double jump section, we add a double jump force set to 77 and a max double jump height set to 22. These variables will be pivotal for controlling the jumping behavior of our character. To ensure precise control and prevent bugs, we introduce a set of Boolean variables tracking the character's states. Under bool states, we have flags such as isStarting jump indicating the initiation of a jump, isJumping representing a regular jump, isDouble jumping for ongoing double jumps, and islanding marking the character's landing phase. In the boolAble section, we use canDoubleJump to determine the character's eligibility for double jumps and canMove to govern its ability to move. These Boolean variables collectively facilitate effective management of the character's diverse states and ensure the execution of specific actions for a seamless and bug-free gaming experience. Now, in the awake method, let's initialize the canMove variable to true. Additionally, in your movement control method, insert the statement if canMove, return, to ensure that the subsequent code is not executed if movement is restricted. Now, let's move on to something more enjoyable. We're going to write the code responsible for triggering the jump for our character. The provided code encapsulates the logic for handling the character's jump functionality. In the handleJump method, it first checks if the character is already in a jumping state, isJumping, and if so, the method exits. Jump button down, and if the character is in contact with the ground. If both conditions are met, it resets the vertical component of the character's velocity, ensuring a clean jump. Now, let's write the following code to apply the jump force in a way that it doesn't exceed a certain height. Next, let's delve into another crucial function. In the following coroutine named startJump, we orchestrate the beginning stages of a jump by setting flags, triggering a jump animation, and introducing a slight delay for a smoother visual transition. This function plays a pivotal role in managing the jump initiation process for our character. Now, let's execute the routine we just wrote within this code block. Additionally, we'll invoke handleJump in the update loop. In this part of our tutorial, we're focusing on the character's descent and landing states. If the character is either jumping or executing a double jump and has a negative vertical velocity while not touching the ground, we trigger the fall animation using the play animation method. On the flip side, if the character is in a jumping state or double jumping, not in the starting phase of a jump, has a non-positive vertical velocity, and is in contact with the ground, we initiate the landing routine. Now, delving into the start land coroutine, it manages the landing phase by setting flags to signify landing, temporarily restricting movement, and confirming that the character is no longer in a jumping state. Following this, we trigger the land animation through our 3D animator controller. A short delay of 0.1 seconds is introduced for a smoother transition during landing. Finally, we re-enable the character's movement capability and reset the landing flags, completing the landing process. This is achieved by calling the start land coroutine using start coroutine. Alright, now let's locate the method responsible for handling movement and executing the run and idle animations. In my case, it's this one. Here, I'll introduce a conditional statement to prevent the execution of the subsequent block. If you don't need to include this, feel free to skip this section. Very well, now let's head to the Unity editor to make some adjustments. First, let's assign the variable for the layer checker in the character controller. Navigate to the Edit option in the top menu, click on Project Settings, and there, locate the Physics tab. Set the gravity value for the y-axis to -30. Now, let's run the game. When you press the button defined as jump in the input manager, in my case, it's the spacebar, the 3D model will jump. As it reaches the maximum velocity in the y-axis, it will start descending, eventually landing and executing the corresponding animations. Now, let's implement the double jump. We'll set the condition that checks if the jump button is pressed, the character is in a jump, not executing a double jump, allowed to double jump, has a positive velocity in the y-axis, and is not touching the ground. Then, we'll write the following code, which resets the force in the y-axis to 0 and turns off the isJumping flag. Additionally, we'll create the method calculateDoubleJumpForce, which functions similarly to the one programmed earlier, with the only difference being the variable values. Now, let's introduce a code segment similar to the one in the jump block, but tailored for double jump variables. Below that, we'll toggle certain Boolean values on and off to prevent potential bugs. Alright, now let's make the following adjustments to the start jump coroutine. Essentially, we are specifying the conditions under which our character can execute the double jump. Finally, let's integrate the following code into the start land coroutine and include this condition using the logical OR operator with isJumping. Additionally, we'll introduce the Boolean isDoubleJumping.
Hola, ¿cómo estás?
And here we reach the end of our tutorial. Your character is now capable of executing a double jump. If you encounter any issues, feel free to compare your code with the provided one in the description. If you find these tutorials helpful, consider subscribing to my channel. Goodbye, and greetings to all.